How is the jet stream changing? Have you ever wondered how the jet stream influences our weather? The jet stream is a fast-moving ribbon of air high in the atmosphere that shapes weather patterns across the globe. In the polar regions, changes to the jet stream are closely linked to climate change and have far-reaching effects on atmospheric circulation and weather extremes. The jet stream forms at the boundary between cold polar air and warmer air from lower latitudes. Its strength and path depend on the temperature difference between the Arctic and mid-latitude regions. The greater this temperature difference, the stronger and more stable the jet stream tends to be. However, as the Arctic warms at a faster rate than the rest of the planet, this temperature difference is shrinking. This reduction weakens the jet stream, making it less able to maintain a straight, fast-moving path. Instead, it becomes more prone to developing large north-south meanders or waves. So what does a wavier jet stream mean for us? When the jet stream becomes wavier, it can stall over certain regions for extended periods. This can cause weather patterns to become stuck, leading to prolonged heat waves, cold spells, droughts, or heavy rainfall in different parts of the world. For example, a slow-moving ridge in the jet stream can bring warm air from north into the Arctic, accelerating ice melt. Conversely, a deep trough can allow cold Arctic air to spill south, bringing unusually cold conditions to regions that are normally much warmer. In the polar regions, these changes can result in more frequent and intense weather extremes. Arctic warming can reinforce high-pressure ridges in the jet stream, causing downstream cold events to last longer or cover larger areas. This can lead to unusual weather patterns, such as extreme winter cold in places like North America or East Asia, even as the Arctic itself experiences above-average temperatures. Research indicates that, as global temperatures continue to rise, the jet stream is likely to become even more variable and less predictable. Some studies suggest that while extreme weather events may decrease in intensity in the polar and middle regions, they could become stronger near the subtropics. However, the overall trend points toward greater variability and more frequent extreme events in many parts of the world. To sum it up, the jet stream is weakening and becoming more wavy due to reduced temperature differences between the Arctic and mid-latitudes. This wavier jet stream leads to more persistent and extreme weather events, both in the polar regions and globally. Arctic warming plays a central role in these changes, affecting atmospheric circulation patterns and increasing the likelihood of unusual weather. These shifts have practical consequences for infrastructure, agriculture, and daily life, especially in regions vulnerable to extreme weather. The evolving behavior of the jet stream shows how changes in the polar regions can have global consequences, influencing weather patterns far beyond the Arctic itself.